And here's a quick review of all of Unit 6. A house is shaped like a rectangular prism. A model of the house has a scale of 1 centimeter, 45 centimeters. So if the model is 15 by 25 by 10, what are the dimensions of the actual house? We set up our proportions. 1 over 5 equals 15 over x. 1 over 45 equals 25 over y. 1 over 45 equals 10 over z. 1 is our model, so 15 is our model, 25 is our model, 10, and 45 is our actual, and that's what we need to find. We cross multiply, we find it. Or all you do is multiply 45 times all three of those numbers. Gives us 675 centimeters by 1125 centimeters by 450 centimeters. What is the volume of the actual house? You gotta multiply those three numbers together. Its base area, which is one of those two, we don't know. It doesn't matter. But we multiply all three of those numbers together, we get 341,718,750 centimeters cubed. It's a house, so yeah, it should be pretty big in centimeters. Make sure you don't forget off any zeros or any decimal points. Just use your calculator. What is the ratio of the volume of the house? We can do this one of two ways. The ratio of the house, 1 to 45, but if we want the volume, we cube that. 45 cubed is 91,125, so it's 1 over that. Or we just do the volume of those two houses. 15 times 25 times 10 over 341,718,750. But then you're dealing with big numbers, but it does reduce down to the same thing. It doesn't matter how you do it. Either way, you still get the ratio. Find the ratio of the volumes of the similar figures listed below. We need to find scale factors. We pick one side to go together. Here in our base, 20 and 16, 10 and 8. Well, 20 and 10 are probably easier to work with. So 20 over 10, reduce that to 2 over 1, and we cube that. 2 cubed is 8, 1 cubed is 8, or 1 cubed is 1, so we get 8 to 1. Could have done that same thing with 16 over 8. It reduced down to 2 over 1. What do you know? Same scale factor, we cube it, we still get 8 over 1. Doesn't matter what you use. Our cylinders, same idea. In the second one, they gave us the radius. The diameter would have been 20. So 36 over 8 is 9 over 2. Or 90 over 20 is also 9 over 2. We cube it. We get 729 over 8. That is our ratio of our volumes. So again, recap, dilations, growing or shrinking a figure, same shape, different or same size, create similar figures. Our image, the second thing, and it has the primes, little apostrophes. To find our scale factor, it's the image divided by the preimage. It's our second thing divided by the first thing. And then we need to make sure we simplify the radical. Some of us had problems with this on the test. Using the distance formula. Or it's the same thing as our circle formula. Same exact thing, just written a little bit differently. You can see the similarities if we square root that to solve for r. Similar figures, congruent angles. Sides are proportional. Notice I did not say sides are equal. I did not say angles are similar. The only things that are similar are the actual figures. Everywhere else, we have congruent angles. We have equal ratios of our sides as long as they line up. And the ratio of the sides is the same as the ratio of the perimeter. Because all you're doing is adding up sides, so it has to be the same ratio. Side splitter theorem and the parallel line theorem. You take this side over this side, equals this side over this side. You turn the picture into a proportion. QR, RS, QU, UT. Set them equal, cross multiply. Same thing with the parallel line. This over this equals this over this. As long as your equal signs are going the same way as the parallel line. Mid-segment, a little bit different. It would also be true, but that's not how we use it. If we have midpoints, and we only know we have midpoints if they give us these marks. That means that LP is congruent to PO, so P is in the middle. LM is congruent to MN, so M is in the middle. That means that this is twice this. And write it out. Volume, you have your formulas. You don't have to memorize them. Just remember that the base area is B, not the base, but the base area. Volume ratio of similar figures, we just talked about that. You gotta cube it. And proving triangles are similar, we have 3 ways to do that. Side similarity, where you set 3 things equal, 3 ratios. Angle, where you prove 2 angles are congruent. Or side angle side, which is a combination of the two. You prove that 2 pairs of sides are proportional and an angle is congruent. Usually we have to use vertical angles or corresponding angles of parallel lines. All that stuff that you've learned back in Algebra 1.